Good morning. We are moving on from area of triangles to area of trapezoids. I think the formula is just a little bit longer for area of trapezoids than it is for area of triangles, but it's pretty much just as basic. You just plug in what you know and simplify and solve. There will be like examples, I think 3 and 4, you will need to solve for a missing dimension. So I believe it says find the height given the area. So we'll have to use the commutative property to rearrange, just like we did with area of triangles, and then use inverse operations to isolate the variable. So that's kind of where we're headed. I'm not going to have you do the got it's today. As long as you feel comfortable with the examples that we do together, then you should be good moving straight from notes to the homework. So no got it's for today. So a trapezoid, we should be fairly familiar with what a trapezoid looks like. We've got kind of two bases, one on the top and one on the bottom. Those are the sides that are parallel to each other. So a trapezoid only has one set of parallel sides. So in this case, the set of parallel sides is right here and right here. Remember, parallel means that they're next to each other and they're never going to intersect. The side that is in yellow and the other side that is in yellow, eventually, if they kept going, they would connect. So the bases are the sides that are parallel, and those are the top and the bottom. Base 1, I typically say is the smaller. Base 2 is the larger, but it truly doesn't matter in your formula because you are just adding them together. In addition, works for the commutative property. The height, just like triangles, has to be perpendicular to the base, so you will see it written as a dotted line, and that right angle will be marked. So the formula for area of a trapezoid is A equals 1/2 times the height times base 1 plus base 2. So refer back to that formula every single time. As a reminder, though, not all trapezoids look the exact same. They still follow the same guidelines. There's still only one set of parallel sides, but they may look just a little bit different. So kind of keep that in mind. If it looks like the one on the right over here, your height may not be given inside the figure. It might be given out here. It might say, 12 inches, and that's fine. So it might look something like that instead of inside the figure. Totally fine. Alrighty, so example 1, find the area of the trapezoid. The first thing we need to do is write our formula. That is our cheat sheet, and we need to write it every single time. A equals 1/2 times height times base 1 plus base 2. And again, if I'm moving too quickly, pause the video if need be. Something's funky with my pen. And then before we start plugging into the formula, we are going to label what we know. So we know A, H, base 1, base 2. Okay, so we don't know the area. That's what we're looking for, so we're going to leave it. The height we know is 7 inches. Base 1 is that top, 5 inches. Base 2 is 12. Now we're going to plug into our formula. So A equals 1/2. Our height is 7. Base 1 is 5. Base 2 is 12. Then I'm going to do, 5 plus 12 gives us 17. All right, 1/2 times 7. You can absolutely do some side work for that. 1/2 times 7 over 1 and get that. Also, 1/2 times 7, we might just know, is 3.5. times 17. So here's where we will need to do some side work. 3.5 times 17. 5 times 7, we get 35. 5 times 1 is 5, 6, 7, 8. And x is 0. 3 times 7 gives us 21. 3 times 1 is 3, plus 2 is 5. So 5, 9, 5. We have 1 decimal here, which means we need 1 here. 59.5. A equals 59.5, and it is inches squared. Alrighty, let's go ahead and do example 2. Again, kind of just plugging into what we know, and we're good. Find the area of the trapezoid. And again, right here, you can see the height is not inside the figure, but it's still written with the dotted line, and the right angle is shown. So start with our formula. A equals 1/2 times height times base 1 plus base 2. And then we're going to label what we know. A, H, base 1, base 2. All right, we don't know our area. That's what they're asking us to find. Height is 9.8. Base 1 is 7. Base 2 is 12. Alrighty, now we plug in what we know. Height is 9.8. Base 1 is 7. Base 2 is 12. 12 plus 7 is 19. I am going to go ahead and rearrange this because I know what 1/2 times 19 is. So I'm going to scoot this guy over. So I'm going to use the commutative property, showing an arrow and rearranging. I'm going to do 1/2 times 19 times 9.8, which is totally fine. Half of 18 gives us 9. So half of 19 gives us 9.5. And again, you're welcome to show side work for that if you need to. You can convert 1/2 to 0.5. Now we've got 9.5 times 9.8, which we've got to show work for. 5 times 8 gives us 40. 5 times 9 gives us 45. Plus 4 is 49. Annex is 0. 9 times 8 gives us 72. 9 times 9 gives us 81, plus 7 is 88. 9, 10, 11, 12, 13, 8, 9. And we've got 2 decimal places, 1 here, so our product, we need to move it over twice. And our final answer, A equals 93.1 meters squared. Again, I worked through that math fairly quickly, trying to keep the video at an appropriate length. Pause the video, work through it slower if need be. All right. Here is where we are finding a missing dimension. The trapezoid has an area of 108 feet squared. Find the height. So we start with the exact same steps. We start with our formula. A equals 1/2 height times base 1 plus base 2. Then we do our bubble of what we know, labeling what we know. AH, base 1, base 2. All right, but in this case, we do know the area. The area is 108. Height is what we don't know. Base 1 is 12. Base 2 is 15. All right, so let's go ahead and plug in what we know. We know the area is 108. 1/2, we don't know the height, so I'm going to keep h as my variable. Base 1 is 12 plus 15. All right, 12 plus 15 is 27. H 1/2 plus 108. Now I'm going to use my commutative property to allow me to rearrange this. 108 equals 1/2. Since I can't do 1/2 times h, I'm going to do 1/2 times 27 h. Now you could absolutely do 0.5 times 27 if you need some side work. However, I know half of 26 is 13, so half of 27 must be 13.5. Now, in this case, we will definitely need to do some side work. So we need to divide both sides by 13.5. When we divide 108 by 13.5, oops, sorry. 108 by 13.5. We cannot divide by a decimal, so we move it, and when we move it in outside, we also have to move it on the inside and bring it up. Now 135 going into 1080 is kind of a good guess, so let's go ahead and take a guess. Let's see, maybe 8 times, so 135 times 8. 8 times 5 is 40. 8 times 3, we've got 24, plus 4 is 8. 8 times 1 is 8, 9, 10. Hey, look at that. So 8 times 1080. So our final answer here is 8 equals h. And it's not just 8, it is 8 feet. So again, side work is always good, always appreciated, and we need it. Alrighty, so again, we're using inverse operations to isolate that variable. That's nothing majorly new. We're just plugging into a different formula this time. Alrighty, now example 4 is the exact same thing. It gives us area. Oh, I kind of rearranged this. It gives us area, it gives us base 1 and base 2, but it does not give us the height. So height is what we're looking for. So sometimes it won't have a picture, it'll just give you the dimensions and what you're missing. So let's start with our formula, always the same process. A equals 1/2 height times base 1 plus base 2. And then we are going to write what we know. So A, H, base 1, base, oh wait, we already did that. I'm silly. So they already gave it to us like that, so we don't actually have to write it like that. All right, so our area is 24 equals 1/2. We don't know our height, so we're going to keep h as our variable. Base 1 is 4, base 2 is 12. So we're just plugging in what we know. 12 plus 4 gives us 16. H 1/2 equals 24. Now I'm going to use the commutative property to rearrange, and instead of doing 1/2 times h, since I can't, I'm going to write 24 equals 1/2 times 16 times h. 1/2 times 16 gives us 8. Since it's 8h, to isolate the variable, we need to divide both sides by 8. And h will equal 3. Instead of just 3, we've got 3 centimeters. Don't forget your units. Alrighty, so this section is not too complicated as long as you get your formula right. So absolutely use your notes to help with your homework. And please let me know if you have any questions.